My name is Tom Petty. I'm with Quantics of Crestwood, Kentucky, and I'm here today to talk about the BioCoir system that we have installed here at this site. Just a quick simplified version of the water flow in the system. It begins at the house, comes out of the house right there. There's the clean out, goes through the house sewer to the inlet side of the septic tank. This is the septic tank right here. The inlet pipe comes into the septic tank, drops the wastewater into the first compartment of the septic tank, goes through that compartment into the second compartment where the effluent filter is located. From that point, it goes through the effluent filter, out and into the inlet side of the ATS dose tank. The dose tank at the outlet end has the pump that doses the treatment module. The pump comes on, pumps the water to the treatment module right here. The water flows by gravity through the media and then out into a collection basin at the end of the module, where it's again pumped back to the inlet side of the ATS dose tank, where we have a splitter located, or a recirculation device. That splits the flow. 80% goes back to the inlet of the septic tank, and 20% goes out the discharge line to the direct discharge and off the property. Now what we want to do is we want to go through the steps associated with routine maintenance of the BioCoir system. We recommend that this maintenance be done every 6 months, and if it's done properly, the system should give long, effective wastewater treatment. The first steps associated with routine maintenance of the BioCoir system would be quite simply to remove all the lids, make general observations of the area, note particularly if there are any objectionable odors or anything like that. Okay, the first step associated with routine maintenance would be to check the sludge depth in the septic tank to determine if the tank needs to be pumped. We'll take our sludge judge, we'll put it down in the tank, through the scum layer, all the way to the bottom of the tank. At that point, we'll pull up on it. We lock it here. And we bring it up. And we can, at this point, determine the depth of the sludge in the tank. As you can see, the dark layer at the bottom, that's the actual depth of the sludge in the tank. This tank's been pumped recently, so there's not a whole lot in there. Looks to be about 4 to 6 inches. And then the clear zone generally is the clearer water between the sludge and the scum layer. In this particular case, there's not a whole lot of scum in it either. Again, this tank does not need to be pumped, but we will check at the outlet end and see if there's any more. I'm going to take one more reading in the second compartment of this tank, the one that contains the effluent filter. And the purpose for this reading is to verify that there is no sludge in this compartment. Obviously, if there were sludge getting into this compartment, then that means that the first compartment probably needed to be pumped. In this particular case, it's not happening, but we're going to check it just in case. So we'll go down and check this right now. Okay, you can see that there's no sludge layer on the bottom. It's a good healthy second compartment of the septic tank. Now, before we move on, after we've done our measurements of the sludge, we just want to record those measurements for the maintenance record so we can determine the pumping interval for the tanks. The next step in the maintenance process would be to clean the effluent filter. And we have a Zabel A300 commercial effluent filter with 1/32 inch level of filtration. So we reach down in the second compartment or at the outlet end of the septic tank. We pull the filter up, keeping it over the tank. Then we rinse it off. That's all there is to it. Now the next step in the maintenance will be checking the pump. This pump is in the outlet end of the dosing tank. The pump doses the treatment module. All right, I'm going to pull the float tree out of the tank so that we can make sure all the floats are operating properly. The way this is set up, we have 3 floats: high water alarm, timer override, timer enable. You can also do this in the maintenance portion, and you can run all of your float checks out here without having to use a rake or anything. So here's our high level check. You notice that turns on the high level alarm. The timer enable allows the timer to control the pump. So put it in the mode of controlling the pump. We'll go ahead and turn that up. What happens here is, as long as this is up and nothing else is up, the timer will operate as it's set and routinely pump to the treatment module when it's designed to. However, in an instance when we get high level, an override occurs, the timer override float comes up and it should turn on the pump, which it does. It's pumping right now. As the water level drops in the tank and the timer override float goes down, it goes back into normal mode, pump cuts off, and now you're back to regular design dosing. What you're looking at right there is a pressure filter. It's on the discharge side of the pump, and it has a 1/20th of an inch level of filtration. The purpose of that pressure filter is just in case there's any large particles, suspended solids that are being pumped that are in the dosing tank, they will get trapped by that filter. And the bottom of the filter has a small hole in it, so it's self-cleaning, and it flushes the water back down into the tank. There's a small pressure gauge on top of it. And the only purpose for the pressure gauge is similar to a swimming pool filter. You just look at it at the readings now and in the future, and if you get a higher reading in the future, then you know that filter might need to be cleaned. And the way to clean it is to reach down to the bottom, unscrew the plastic holder, pull that filter out and clean it just like you would the other effluent filter. But again, it routinely or rarely needs cleaning because it is self-cleaning under pressure. So, all right, the key to putting the float tree back down in the tank would be to make sure that the cords are not wrapped around the floats themselves. You can wrap them around whatever you might have in the thing. What we're going to do is we're going to use a zip tie, loop the cords up here, tie it to the top of the pressure filter, and it keeps them out of the way. And now the floats are free to operate as they need to. There's a locking mechanism on the side of the pump vault. It allows us to lock that float tree in place so that it won't come up or go down, and then it makes it available if we want to pull the floats out the next time. At this point, we come back to the control panel, and we're going to do a couple of things here. The first thing we're going to do after we open the panel is we're going to test the alarm switch, just to make sure it works at the panel so that it'll notify the homeowner in case it gets into alarm condition. So there's a switch on the side of the panel. We hit it, push it to test, so we know it works. The next thing we're going to do is we're going to turn our pump, which is routinely set on auto or automatic down to hand to make sure that the pump comes on. Now the pump's on. We know the circuit's working, everything's working the way it's supposed to. Now we'll set it back to auto, and that's really all there is to check here. We're at the BioCoir module right now. It's a fiberglass module, and it contains the core media. And the first thing we're going to do is we're going to turn the pump on and observe the spray pattern from the nozzles. Good. Now what we're looking for is a conical spray that covers the entire area, which we seem to have. We'll also note the pressure reading. At this point we're reading about 4 psi. To achieve the proper dose through the 4 nozzles that are in the module, we need to be right around 5 psi, so we're pretty close. But if we want to adjust it a little bit, we do it with this ball valve. So we're right at 5 psi now. Everything's the way it should be. We got 4 nozzles, all 4 of them seem to be spraying, but now we want to take them off and check. We've turned the pump off, and we're going to take the module, the nozzles off, the spray nozzles off, to make sure that there's nothing plugging them up or they need to be cleaned or anything like that. It's quite a simple operation. It's a clip. You undo the clip, and there it comes. You want to look in it, make sure there's nothing that's clogging that up. If there is, you can clean it out with a small stick or a brush. They can even be washed. They're quite simply off-the-shelf agricultural spray nozzles. Now, once you've done that, quite simply to put it back on, as you put it back down, there's a hole on the bottom. It fits in it nicely, and you clip it back on. Then you check the rest of them. Then check for leaks. The final item to check in the module itself would be the media. The media is a biodegradable media, and it ultimately will have to be replaced. This particular system has been in about 4 years. When the system was delivered new, the media actually was about 6 inches below the spray nozzles. Over a period of time, the media settles. That doesn't mean it's bad. The real way to tell if the media needs to be replaced is in the testing. If the performance is adequate, don't mess with it. However, when you get to a point like this where the media has dropped probably a foot, you need to start looking at whether the media has actually degraded or simply settled. And in this particular case, the performance is still good, and I think what we need to do is we just need to see if it's settled. You can do that with a rake, and what we'll do is we'll go down and we'll rake the media, and as long as we keep pulling up fluffy media, that's really all it is. It's just settled. So otherwise, what we would need to do is add some more core material to the top of it, which is quite easy to do. And what we're going to do is we're going to take the rake, and what we're going to rake some of the media and go down and see how deep we are and if it's still fluffy, and it is. So obviously what has happened with this media is it's just settled. You could continue to do this. It might bring it up a little higher. If we were to go in there and it was similar to a sludge, that meant that that media is breaking down and it did need to be replaced. In this case, we can see that it's still nice and fluffy. One thing you need to remember is when you're in here raking and fluffing the media, don't pile it up under the middle. Pull it up, fluff it up, and then level it back out. Like that. The final maintenance item on the treatment module itself is the air vent. Now, all aerobic systems need oxygen. This is the source. This is where the oxygen actually comes into the tank. It's a passive vent system, but because it's open to the media below, it's possible you can get some odors. So you routinely, what you do is you just take the top off. There's a carbon filter pad that is replaceable. You might want to replace it once every year or so. If you start getting odors, it might be that the carbon in this filter pad is worn out and it's time to replace it. Once you open this up, you want to make sure there's no insects in there, which there seem to be right now. There's some spider webs. Clean that out, make sure there's nothing else in the pipe. Put your filter media back in and close it up. The last apparatus that you need to be concerned about would be the recirculation device, or the splitter. The purpose of the splitter is to split the flow after it's been treated in the treatment module, 80-20 or 4-to-1. 80% of this flow will actually be collected and sent back to the headworks of the septic tank. 20% then is discharged to the direct discharge line. There's not a whole lot that you can do as far as routine maintenance is concerned on this. The main thing is that when it's installed, you need to make sure that it's level as possible. So in this particular case, we've got pipes going into side walls. We're not going to be able to move it much. So in an instance where you're installing a system, you make sure that this device is level. And you do that by putting a level on it, quite simply. The way it splits is the water comes in from here, goes out these 4 crosses both ways. That's 4 splits, and then the final one goes out this way to the discharge, so that's 5. So 80% of it goes back, it's collected and goes back to the septic tank, 20% goes to discharge. In an instance of low flows, where maybe somebody's on vacation or they're not using the water like they normally would, there's a float that comes up that's in the water, and if it drops to a certain level, low, it will close off the discharge line and 100% of the flow will go back to the septic tank, so that you'll always have water going through the system, keeping the media active and viable. And then when the water level picks back up in the house and the water use picks back up in the house, that float rises, opens up the discharge line, and the water goes out to the discharge. As part of routine maintenance, it's very important to check the readings on the panel, to know where you were when you started and know where you will be after the next maintenance cycle. For instance, this meter right here is a counter. All it does is counts the number of times that the pump has come on. Knowing that our dose is 12 gallons per minute, we can refer to this counter, which is a timer, and will tell us how many minutes it's actually run since the last visit, and whatever the flow is at 12 gallons a minute times however minutes, that's how many gallons of water we've actually pumped through the system. And then the final thing would be the timer settings themselves. This is a little analog timer, and actually the green arrow points to the off time and the red arrow points to the on time. It's set in minutes, so in this particular case we've got 7 minutes on and 27 minutes off. If it ever needs to be adjusted because of water use changes or anything like that, it's quite easy to adjust it right here. Okay, so now you record all these numbers. The number of cycles, the cycle counter is, and then you record the pump run indicator. It tells how many minutes that the pump is run. So now that you know, now that you've recorded your number of cycles and the time that the pump has run since the last maintenance visit, you can do the math and figure out how many gallons of water actually went through the system in that time. And once you figure it out based on the design flow from the house, the daily flow or daily amount of water that should go through the system is 5 times that design flow because of the recirculation of the wastewater back to the septic tank in a 80-20 manner. So if you have more water than that, one of two things has happened. You're either using more water than it was designed for, and that can be verified by the homeowner and looking at their water bill, or you might have a leak. You might have plumbing leaks that are causing more water to go in through it. You should be able to tell that by the water bill. One thing that you can also tell is if you're getting groundwater leaks into the septic tank. If, for instance, you're not showing any increase in the water into the house or the water out of the house, but you're seeing more water flow through the system, then it's quite likely the septic tank might be leaking, groundwater's getting into it, and you're treating groundwater in addition to the wastewater. So that's part of the value of recording these numbers every time you come out so that you can go back and troubleshoot the system if you ever have a problem. One optional feature of this system is a separate pump to take the water that after it's been treated in the treatment module and send it back to the recirculation device. The reason that you might want to have one of these would be to be able to keep everything below ground. The way the system works is gravity, the effluent has to flow through the media and go out by gravity at the bottom of the treatment module. Now, one way to allow this to be done and bury the thing would be to maybe have the module up on a slope so that you could get the gravity flow back to the recirculation device easily by gravity. If, however, you have a flat lot like this one, you can put a pump at the end of the treatment module, a small pump that all its purpose is to send the flow back to the splitter device or the recirculation device, and that way you're able to keep the whole system underground, and you're able to landscape it and make it aesthetically pleasing. And as far as maintenance is concerned, the only thing you'd want to do here is, make sure that the pump is still working, because there's no time. This is a demand dose pump. It's not a time pump, so it comes on when it needs to come on. And as long as it's still working, everything's fine. One of the most important things you've got to do is to put the lids back on, make sure they're locked in place, screw them down, screw the lid down, make sure it's tight so nobody can fall in it. Go back to the control panel, set it in auto position, make sure everything's ready for the pump to run the way they're supposed to, and everything operates automatically.